Good morning, April 29th. We're going to back up a little bit. I did not cover something I intended to, and you all let me off the hook. I wanted to show you how a table structure is represented in um, what's called an entity relationship diagram, because we talked about a table is kind of an entity, like a person or cars or um, departments. That there's a in that design where you're laying out your tables and going through that normalization process. Um, you will come up with entities, and entities have attributes, and the entity is the table. The attributes are the columns that describe each of you know each of your rows in that table. So it's called an entity relationship diagram. You guys have access to it. I put it in the classroom. Let me share my canvas here. Um, One thing I'm moving towards is organizing these files a little bit better than this. This main home modules is kind of cool, but I think there's a better way to store, especially if you have a lot of files like we're starting to get to. I think putting them over here in files uh, um, later, if you want to check it out, click on files and you'll see I created a Python notebooks folder and a Python books folder with a bunch of PDF versions of some really cool Python books if you want to grab copies of those. But I wanted you to pull up the Northwoods ERD.PDF here in the SQL overview section. Um, so you're going to need to pull that up in probably better to do it in uh, PDF viewer. So I'm going to grab that. The Northwoods ERD. Okay, so now let me do a new share of that. Okay, so there's a tutorial also in the classroom that walks you through this as well. So you can rely on that as well as me talking to you. But this is what's called a physical database diagram, a physical ERD, a physical entity relationship diagram, and it's physical versus logical. It's physical because it's showing an actual database that is actually created in software with real tables and real column names and an actual primary key field. The name of the table is in gray up here. Each of those are tables. So as you remember in Workbench, when we were doing those queries, we've got students, and we have courses, and we have, let me see if I can't maximize this. And you're welcome to, like I said, you're welcome to follow along in your version of it. And we have faculty members, and this is just a super small example database of like a community college, the Northwoods Community College. So each of these squares are a table in that database. And so those are the entities in the entity relationship diagram, those tables. You will also see these lines connecting the entities, connecting the tables, and remember yesterday we were talking about the one-to-one relationship and one-to-many relationship and many-to-many relationship. Well, when you're looking at an ERD, and this is a fairly common, I think this is called information sciences notation. Um, the way these lines are terminated. So as you can see here up in student, we've got the primary key is S underscore ID, which is student ID, and it's a numeric field. Um, and then you have down here in the under PKC FK1, that's foreign key one. So F underscore ID is a primary key in another table. That's what foreign key tells you. So this tells you that uh, now look at the line in between the student and faculty table. That tells you um, that and see it's this F underscore ID that it's telling you that that's what it's describing is that relationship. Faculty ID is the faculty advisor for the student. And the faculty, and you see what looks, I guess that looks like a male symbol, doesn't it? The circle with the plus sign, um, that symbol is 0 uh, or 1. The one up here with the three pitchfork looking thing um, is the symbol for 0 to many. And what that's telling you is that a faculty can advise many students, but a student can only have one faculty advisor. So that's where you start to see the relationships among these tables. And given an entity relationship diagram like this, you can start to think of how you would query detailed records. You know what I mean? So that you would start to query data out of more than one table. And I kind of needed to go over this because today's short lesson in SQL is where you start to relate more than one table and pull related data from more than one table. So let me look at some other symbols here. Like a course section. So you got the course section table here on the upper right corner. It has a relationship with faculty where a course section can be assigned to 0 or 1 faculty. And if it's null, if it doesn't have a faculty ID in there, that means that course section has not been assigned faculty yet, which is a piece of information you could, which could be useful. So it's the relationship there is 0 to 1. So, but then there's a 0 to many up here at course section because a faculty member can teach 0 or multiple course sections. You guys starting to get any questions with how
What's
that lays out?
4?
Gabe, go ahead.
What's that 6 for?
I don't know. I'm just noticing that this is the ERD for our sample database, and I don't remember when my buddy Jim Downey, Dr. Downey, was teaching this last time, what those different numbers meant. I don't know. And you won't see that. I don't remember seeing that in other ERDs. It might have just been something to accompany a lecture. You know what I mean? I don't believe it has anything to do with it. But like the F key 1 and F key 2, and then you see up here in course section, there's 4 foreign keys. So that starts to show you how interrelated this data can be. And I wanted to show you an example of like a many-to-many relationship that has been turned into an intermediary table. And I think course section is the best one to do that. Because, like a faculty can teach many sections, but a section has to be taught by a faculty. Students can be enrolled in many sections. So you've got this enrollment lookup. So you got lots of students, um, of course sections. So you have this lookup, this intermediary table called enrollment that is your link between what students are enrolled in what course section. Otherwise, if you tried to put it in course section or student, you'd have all this duplicating information. You know what I mean? You wouldn't want to put all your student information in the course section table because that's about an actual offering. The course section table tells you, the biology 101 is at this time of the day and it's in this room and it's course section number 17352. You know what I mean? So that's a particular offering of a course. Now, the course table call ID is like biology 101. Well, we can offer 8 sections of biology 101 at a major university, but each of those sections will only be taught by one faculty member. So you can start to see the relationships making sense, and the diagram. There was a couple of other symbols here. Oh, the what looks like a telegraph pole. I don't know if can you see that when I highlight it in blue? Okay, that telegraph pole is one and only one. So let's see what that means here. That means course section ID. A course section can have many student / section IDs, but each combination of student and course ID will be in there one and only one time. I'm confusing myself now.
Hey, Don.
But that's what that symbol means. Go ahead.
I believe that the numbers in parentheses are aren't those the number of characters that's allowed in that entry? So like varchar 2 there would be 30 characters max available to input, right? Isn't
Correct.
that?
Yeah, that's for varchar. That's the maximum number of characters, and in care, that is the number of characters that it accepts. But I think what Gabe, correct me if I'm wrong, I thought you were looking at like number 6 and 5 and 4.
Yeah, I was.
Yeah, beside the table
Oh,
name.
okay. I thought we were talking about the other numbers and parentheses. Okay.
Yeah, but that's a good point. This physical entity relationship diagram shows you pretty much everything you need to write a query. There's another document that goes along with this called a data dictionary that would actually describe what max underscore ENRL, which we can all, assume means max enrollment in that course section. But a data dictionary would tell you more about each and every field in the database so that you knew what you were using. Because some of these get really complicated and you virtually can't give it a meaningful column name without it being 60 characters wide. So that's an ERD. Again, first exposure. Those are the symbols. When you see the forks, that means there's a something to many relationship. And when you see the single line, whether it's one cross or two, that's a something to one relationship. But rather than that, let me stop sharing that one. So you've got a copy of that, and that is your description of our database. Now, some of the data types, this is in Oracle, so the data types might be different, but you don't normally have to specify the data type, you know what I mean, in a query. So just be aware of that. And it's very it's a great learning experience to get something that's kind of wrong and you have to troubleshoot it. And that's what I was doing with queries on our PowerPoint today and yesterday, is converting Oracle syntax into MySQL syntax. And it's just a character here and there, but it really matters. Okay, so that's an ERD. I'll put that away for now. But there is a in your files here, this very top thing, entity relationship diagram. Let me share that. The very top thing is the tutorial I was telling you about. Screen share that tab. So this is worth, it's a 10-minute read. It's worth your time. This is coming from a company that produces a tool that lets you draw entity relationship diagrams, but you can draw them in PowerPoint. Access generates them automatically. So you've got, again, logical or conceptual. Here with logical data models. You've got symbols that in the design phase are what you want to use when you're drawing things. And this one goes over those different design level concepts. So like when you're coming up with entities, it tells you how to draw them. I don't really know their methodology as far as strong, weak, and associative entity, and that's a database design issue. So I don't want to deep dive into that. But what I wanted to show you down here was these symbols. Now it gets into the physical diagram, which is like we saw, where you have the actual table name and you start to see column names. Yeah, and you'll annotate the key. Yeah. And you're starting to see relationship symbols here, which is what I wanted to get down to. So you guys should read this page on your own at your own pace. Okay, so these are the symbols that you'll see at the end of those lines in between tables. The line terminating by itself means that whatever's over there has one, and the vertical line means one. Then the fork means many. One and only one is a constraint. Generally reflected by putting not null when you create the table, but it wants you to put a value in there. 0 or 1, 1 or many, 0 or many. 1 or many is generally, you don't want a null value in the table. So that's what those symbols mean on an ERD. And like I said, I got another one, but it's not in this format, so I don't know if it'll be confusing or not. But we've got the Northwind database, which is the one that comes with pretty much all Microsoft database tools. But I don't know that I have an ERD for Northwind in this format using the right column names, so I'll keep looking. Anyway, that's an ERD, and that's the physical depiction of a database design. So if you're working with data at work, you should be able to ask your database folks for an ERD for the data. If you get crazy looks, it's because they're not database designers. They're just database folks. They just know how to keep it running. Or maybe they learned it with a different term. But when you're working with a production database at work, you should have access to documentation to show you what the what the structure of the database is, or you'll be sitting there describing tables and trying to figure things out for way too long. Any questions on what an ERD is and what it does for you as an analyst? Alrighty.
Don,
Go ahead, Dan.
is there a difference between a dashed line and a solid line?
Yeah, let me look that up. I don't think so, but let me Google it. We're stop share. Dashed line versus solid on a database ERD. A dashed line means that the relationship is strong, whereas a solid line means that the relationship is weak.
Okay.
And
I saw
there's
both on the other one you showed us.
yeah, and it's on Stack Overflow, which is Stack Overflow is the computer nerd answer site. And you know what? That is beyond my immediate grasp of the topic, Damon. I don't know, and you know, I don't remember from so far back the concept of a strong or weak relationship being something. You know what I mean? I don't remember that being a factor. It's either related or it's not, and it's either a field that can be null or it can't. You know what I mean? I don't remember a strong or weak relationship, but
I got you.
that's what that
No,
means.
that makes sense. Thank you.
Okay. Let me see. All right, so I wanted to do an ERD, and I wanted to go back real quickly and do multiple table queries. So let me bring that up real quick, and then we will quit working with SQL, and we'll use the rest of the day for Python. I got a few notebooks I want to get through. Up comes. All right, the internet's still alive. Okay, so in the classroom, make sure I posted this. In the classroom, under the relational databases SQL module, yes, you have multi-table queries. DAAT16 March 2021, multi-table queries. So what we did yesterday, bring this up. What we did yesterday was the very beginning of pulling data. And sometimes you can get what you need out of a single table sometimes, particularly if it's just a raw um, report on like personnel. You know, you pretty much have their name and address and whatnot on there. And you can get some useful information out of a single table query. But lots of times you've got to pull data out of more than one. So let me share that PowerPoint. You can follow along either on my share screen or on the PowerPoint, whichever you like. Because there are some, I think I troubleshot all of these and made sure I got the Oracle goofiness out of them. So yeah, multi-table queries. This is where you start to get something like, you know, and a student and the courses that they're enrolled in, not just information about that student by itself. And you need to know the relations and the foreign key so that you can link, you know, link the tables appropriately. All right. 902. All right. Retrieving data from two tables. And of course, the strength of SQL and a relational database management system is being able to combine data and keep it, have it make sense. It's called a join. You are joining tables based on that key. So it logically it starts to take those two tables and denormalize them and create one kind of, they call it a Cartesian, you know, it creates one kind of one table for you to work with when you start exporting the data to Excel or something like that. It's easier to see what I'm talking about. But there is a join keyword that we will learn, but you don't have to use that join keyword to join data from two tables. What you would do is select, you know, columns, field name 1, 2, 3, 4, from multiple tables. We're just doing two now. And then in your where clause, instead of saying like, where something is greater than 5, you would say where your first table dot, and we'll get to it, whatever key is joining like students and core and sections, s underscore id, whatever the key in your first field is that you want to have equal to the key in the second field. So they can be different names. You know what I mean? They don't have to be the same name, but they do have to be identified as the foreign key. So, like I said, it'll be easier when you see an example. And you
unique values, like it has to be a field where there aren't like multiple of the same value.
You are you getting into the distinct clause, Laura?
Well,
or
wondering how the query would work if like there were multiple of the same value, like how it would know to match.
In your where clause, if you didn't use a where clause, I think it would join every instance of one with every instance of the other, and you'd have every combination. And I think we got an example of that, Laura, where if you don't limit it down, or if you don't join the tables, you get this every combination of both of them kind of thing, Apologies. But again, playing with these and seeing it with real data is going to help here. But that's the basic. I beg your pardon, guys. Good grief. Now, okay. So that's the basic syntax for pulling data from tables. Now, maybe getting ahead of myself, but field name 1 and field name 2, if they are unique to table 1 or table 2, it'll figure it out. If last name, if you select last name, comma, brand of car, and last name is in your first table and brand of car is in your second table, it will figure it out. But I want you to see here why I'm saying that is because I don't want to confuse you here. This is how you qualify which table you're talking about. If you're using S underscore ID for student ID, and you're using that column name in more than one table, it can confuse SQL if you don't qualify that column by putting the table name and then dot in front of it. So that table 1 dot S underscore ID equals table 2 dot S underscore ID. Now it knows, oh, where everything, from these two different tables, man, it'll error. It'll tell you I don't know which one you're talking about if you don't qualify them and you use that column name in more than one table. But again, let's get to the examples. Select and from clauses list fields to be displayed and the tables involved. Yeah. So it'll only show you field 1 and field 2, regardless of what's in your where clause. It will only show you those two. Now, you don't have to select a column from both of these table 1s and table 2s. Sometimes, make sure I'm not getting ahead of myself. Sometimes you need to join the tables, but you don't necessarily need to display what you're joining, I guess is what I'm getting at. But again, let's get to the examples. So here we go. We've got two F underscore ID columns. You got FID in your faculty table, which shows you the faculty identifier for professors Cox, Blanchard, and Williams. And then in the student table, you see FID repeating. You see Cox is an advisor for 3 students, for Sarah, Brian, and Daniel. Blanchard is an advisor for Amanda, and what's his name, Williams, doesn't advise any students. But you're using the same column in both tables. So if you're ever referring to both of those tables, you're going to have to tell SQL that student dot f underscore ID versus faculty dot f underscore ID, and it will figure that out and do the join appropriately. Okay. What happens if you select a field name, select f underscore ID, say, that appears in both tables? FID appears in both tables. You must qualify the field name in the select clause. That's where you would say select student dot f underscore ID. To qualify, you must tell MySQL which table to use, and that's table dot column notation. Yeah, this first query is bad because it doesn't tell the database which table to get FID from, because it's in the faculty table and it's in the student table. So you do this, but yeah, I was trying to figure out exactly where Jim was going with this. Beg your pardon, guys. Robocall. Yeah, I think I'm getting ahead of myself. If you don't qualify them, you start getting these crazy joins, and you'll see the difference. This bottom one works, but it does that crazy Cartesian join where you get all the students and all the faculties linked together. Okay, and the where clause. Now you can limit things that are not joined in the table, but the where clause has to have the join condition in it. So yeah, it's got to have the join condition, but it can have other things that limit down the data that you're looking at, and they can be very complex. Okay. Yeah. Like table 1 dot primary key, table 2 dot foreign key to table 1. That's all that's saying. Trying to get to yes, and you can have more than one search, more than one where condition using the ands and ors. And this is there are inner joins, left joins, right joins. There's different types of table joins that we'll get into somewhat. This is referred to as an inner join, but again, you don't even have to use that join keyword. So I'm kind of belaboring the point, I believe. So there you go. That shows you how faculty ID is related. Here we go. So let me grab this. This is we're pulling the students first name and the last name of their advisor. See, F underscore last is in the faculty table, but we didn't have to qualify it because it's only in the faculty table. We didn't have to say faculty dot F underscore last. Everybody, and same with S underscore first, because it's only in the student table. We didn't have to qualify S underscore first. Sorry if I'm going too slow with this stuff, guys. I just want to make sure I'm getting these points down. So let me pop that into Workbench. And I was doing lots of SQL last night. And we'll see if this runs without goofing up. There we go. Yeah. So we got student ID, student's first name, and then the faculty ID from the student table. See student.f_id, and then the faculty's last name from student and faculty, and then you link them where the student FID equals faculty.fid. And that's how you grabbed the last name of the faculty member, was because of that where student.fid equals faculty.fid. That's how you equated the last name of the faculty member to the student's name. Any questions on that? Just conceptually, I know it helps to play with it. Any questions on what's going on there? Or is this pretty clear? Who's never worked in SQL before? Gabe, have you done SQL before?
No, I haven't.
Is this making sense?
Yes.
It is. You're kidding me. I'm making sense?
Yes.
Wow. Okay. Well, all right then. So yeah, that's how you start to get related records about someone. Now this one isn't super informative because you're just getting, you're just fetching the last name from a related record, but it can be more interesting where you start to fetch, like, every order for all of your customers. So it'll go through and show you a customer and then all these orders, then the customer and all these orders, and you start to get much more information. And then for that order, you can get the details of the things that were in that order. And as you get more and more complex databases like Northwind, it gets to be a little more cosmic. Okay, let me see how much I got more to do here. Ugh. I'm going so slow. Okay, this is I'll take a break right after this one. This is using, instead of putting the primary key equals the foreign key in the where clause, you can use this join, inner join command, inner join clause, in your from clause. In my experience, we wouldn't do this. We would always use the table 1 dot field name, table 2 equals table 2 dot field name. But you can cut and paste that and run it, and it does the same exact thing. But some queries that you see written use that join terminology. So if you're using someone else's queries, or if there's a coding standard for writing queries, and you have to learn the join syntax, then that's what you're going to have to do. But that's how that works. You're joining student and faculty on these two key fields. Now, I believe if they were named differently, you wouldn't have to have the faculty dot and the student dot, but it's good practice anyway, so that you know what you're looking at. So that's the inner join versus, explicitly using the join clause versus just doing the logic. So when we come back from break, we'll do a few more examples and then we'll move on to Python. Okay, see you at 9:30. Cell phone time, 9:30. Any questions before I go on my break? Okay. See you back at 9:30, guys. And I'm going to pause recording. Okay, and we're back. Okay. So, yeah, just getting back to the principle at hand here. What goes in your select statement is what gets displayed. The join field are the primary key and the relative foreign key that you're joining that data on, just like we did with faculty advisors and students. And then your search field is your where clause, and that can use any condition from either table to limit the number of rows that you're getting. So we could have put in our where clause where student gender was M or F or whatever, so you can modify that as well, but you got to make sure you got your join condition in there. And then let's try another query. Let's see what we got here. Display the course section ID, the day, and status. One of these errors, I think. Let me see what we got here, because I had real trouble with time data going between Oracle and error code. Unknown column closed. Oh, yeah. Yeah. Man, I went round and round with this one. Status is a keyword in MySQL, and it let me create a status column in a table, but it errors. I get a SQL error even if I try to rename that column away from being status. So that blew up. So that will not work in SQL Workbench. Okay, multiple table queries are essentially the same as two table, true, and you just got to link the subsequent related records. Let's see what we got here. Okay, a query that lists the last names of faculty members that teach during summer 2007. Faculty, term, and course section. Let's see what we got there. Okay, so all we're going to display is the last name of the faculty. We're selecting from 3 different tables: faculty, course section, and term.
Don, will you share your screen? I don't.
Oh, yeah. What? You're just now, is that what you're, I could see you going,
I wasn't sure.
He doesn't know, does he? He doesn't know he's not sharing the screen. Oh. Guys, slow me down. Share entire screen, because I'm flipping back and forth. There you go. I apologize. Okay, so yeah, back to our query. We're selecting F_last, which is only in the faculty table. So we don't have to say faculty.F_last, even though we're selecting from 3 different tables here in our from clause. But we do have to select them, or we have to list them in our from clause if we're going to join data from them, so that the SQL statement knows what we're doing. And then so that's your from clause. We know we want related data from these 3 different tables. So now we have to start doing the joins, and this is explicitly without using the join keyword. So we say where faculty ID equals course section faculty ID, and course section ID term ID equals term.term ID. Because remember, in a term you can have many course sections, but a course section can only only appear in one term, like a semester, and we're only pulling summer 2007. So that's what I'm talking about. In the where clause, you have your join conditions, but you can also have just any other limiting condition, as long as whatever column you're using here is in one of those tables. You know what I mean? You can't, it's got to be in one of those tables. So let's see what we get there. If I come over here and paste that into Workbench, Thomas, when I do Workbench, can you see the font, or is it too small?
I can see it.
You can. Okay, it's tiny. When I get done yapping here, let me see. Up term underscore just. It doesn't like that. Why doesn't it like that? Nope. Nope. Why doesn't it like a blank in there? I thought I ran all of these.
Could you do an underscore just to replace the blank with a?
Yeah, because the blank will match a space. Was that Laura? Was that you?
Yeah.
Yeah. Because underscore is the wildcard character in a string like that to match anything. So that would match summer space 2007, and it would match summer exclamation point 2007. So, but why can it not handle the space in?
I know, and you confuse me with the double quotes because a lot of programs like require the single, like double quotes are confusing unless it's an alias. And then I always use a single quote for like characters or values.
Yeah. Well, I thought I ran all of these queries in this PowerPoint so that I wouldn't have a senior moment in front of you. Let me see what we get here. Oh, and instead of clicking on lightning, if you just hold Control and press Enter, it runs the script. Control Enter on a PC. So this is showing, but it's not limiting to the term description. So this is bugging the heck out of me here. I'm gonna fly without a net here for just a sec. Fly without a net. Trapeze without a net. Slick star from, is it term? From term, dummy. Term underscore description. Yeah, term. Is there a chance that I've got to qualify, that it would help if I qualified it? This just is not making any sense, and it's bugging me. Sorry, guys. But this is exactly how I learn, is by fixing stupid errors like this. What? That doesn't seem to fix it. And the let's use like instead of equals. Maybe that's the problem. Summer anything. Anybody see what I'm doing wrong? I do not get it. Is term description, am I using a search term that's too long for term description?
Select term description, or can you filter on like you, so you can use a conditional without having it in the select clause?
Correct. Yeah, because it's one of the tables that we're selecting from. But let's run that. At least doesn't got the stupid squiggly line anymore. Unknown column SUMM in the where clause. There's got to be something.
Maybe it's the join, because when I've never used the where clause to join, but it makes it think like you're continuing to do join clauses.
Well, I don't think
Where
Oracle. Yeah, I don't think Oracle had any trouble with this.
you have
But
to do it.
I'm spending too much time on this. I need to troubleshoot that and figure out what I'm doing wrong. And if I got to rewrite it, in fact, it may be. Yeah, this is the one that errors for sure. That term.status doesn't work. But I can rewrite that when using the join statement, but I don't want to fumble through it and waste your time. So I can't remember if we get to that. Let's see. It seemed like this one worked. God, I could swear I troubleshot all of my queries here. There's something going on here, guys. Let me get an entirely new tab. Yeah, I'm Is that what I'm doing wrong? Did I misspeak? I've been changing. I was thinking that Oracle liked single quotes, and I've been changing everything to double quotes to get it to work. But now it's goofing with me. So that's what the problem was. Was I was using double quotes instead of single quotes. So anyway, yeah. So all we're selecting is call ID and the grade that the person got, where it's for Sarah Miller, but we don't have to display Sarah Miller. But you can put it in the where clause. I noticed that all of our joins here are done, student SID equals enrollment SID, enrollment CSEC ID equals course section CSEC ID. So these are all qualified and they're all linking together. So this is basically pulling the correct section that Sarah Miller was in, but only displaying the grade, the actual course that she took without displaying the section ID, which is just kind of confusing. So that's pulling from 3 different tables and joining them all explicitly using the where clause. What happens if you leave out a join field? It won't error check. I think we got an example here. So we're selecting student ID, student last name, student first name, student.faculty ID, and faculty last name from student and faculty. But you notice we don't have any join student, join on student.faculty and faculty.f_FID. See, we're not joining them at all. We're just selecting them, and that results in a whole great big mess, like we were talking about, Laura, where you get that for every student, you get every faculty member because you didn't tell it how to link the data. So it goes, okay, I'll do one for all of them, and you get a bunch of junk. So you can kind of, as you go through your output and it doesn't look like what you were expecting, you can kind of tell when you've done a join incorrectly. One more. Yeah, and this adds the join of student faculty ID and faculty ID to correct that problem. That is still bugging me about the quotes. There you go. So this now you get a since you joined it, you get a unique one row for student, and then you get their faculty advisor because you did the appropriate join up there. So I want to back off of that, but I did want to show you something. Any questions other than maybe playing with it some? Got some exercises, and what I want to show you next before I move on to Python is the coolest website for learning SQL that I've ever seen. I was on it for 2 or 3 hours yesterday. So kill that file, exit there. I'm still sharing my whole screen, right? Okay. So you can just Google this up. It's called World Wide Web Schools. We talked about it yesterday or Tuesday. Coding stuff, SQL tutorials, W3 Schools MySQL tutorial. So it's w3schools.com/MySQL. And man, it's cool. It is awesome. I was down here. I wanted to look at functions to see just how much I wanted to cover, because you can select a raw column that's just the data in that column, or you can do something to it. You can do, math to it. You can figure out the square root of numbers. You can pull just the first 4 characters of a var char. There's all these different functions you can do, just like Python, just like Excel. So I was going down here I clicked on MySQL functions, and you guys are welcome to follow along. But like, I just started clicking on these because these are all things that, as a programmer, you kind of are routine tasks. So what I wanted to refresh myself with was how SQL did it. But the real cool thing here is like, say you've got data in lowercase and you like all upper. So it doesn't change the data in the database, remember, when you run a function on it. But so click on upper if you're following along, and then click on try it yourself, and it opens up a new tab where you can execute the SQL, and it's got a copy of the kind of similar of the Northwind database that is used for Access training and MySQL training, and we've got a copy of it here, and we'll work with it a little bit more. But you can run this. So if you run that SQL, it's talking to a SQL engine behind this web page. It's returning SQL tutorials is fun, and it's not just canned. You can type in anything and execute it and run it, and it works. So once you get this thing, I mean, it puts in the example of what it is you're playing with, the function, or there's joins, having clauses, there's all kinds of stuff in here. Once you get it in there, you can modify it as much as you want. And then when you're done playing with SQL, you close that tab and you're right back where you were in the tutorial. But like, these string functions are the kind of stuff you'd think of if you're working with a character string, like name or company name or whatever. You can pull, you can trim spaces. You can pull the first 4 characters or the last 4 characters, no matter how long it is. You can pull from character 2 to character 6 exactly. And you just put that in your select statement, like this select upper of that stuff. Yeah, if you're just doing something with a string literal like that, you don't even need a table to select it from. It just works with you. So yeah, all these different SQL functions, and then you've got numeric stuff like arc, cosine, and tangent, and all these different, modulus. So you can get you can do division and check for the remainder, and you can get just the remainder. There's all those sorts of mathematical functions over here. If you're doing, like some of you are looking at, I think it was maybe Erica or Lindsay are looking at days between a security incident and the closure date. You can do date math in SQL, so that when you're doing your select statement, it's going ahead and doing that stuff for you, so that you don't have to do it in Excel or Python or your follow-on tool. So there's all kinds of different conversion functions and whatnot, kind of like you would think. So it's good, but this website puts them in a usable, organized, place and then lets you play with them. So I thought that was way cool. So if you guys can get me to stop talking today before 12:30, I would, rather than working with SQL Workbench or anything like that, this might be as good a use of your time. But I
Do they
also,
have a sample database that you could?
they do have a sample database in here. I couldn't download it, but it is the Northwind database. So let me
Okay.
let's see if we like MySQL examples. If you click on this down here, it starts to give you examples to play with. And over here, Laurie, see MySQL database has got customers, categories, employees, order details, orders, products, shippers, suppliers, and lots and lots and lots of records. This is very similar to the Northwind database that we have, that you can double click on and see the tables in SQL Workbench. But there's more data to it. There's more records. So here's where you got, like select star from customers, and you can execute that. So we run SQL, and it's actually executing against that sample database. I want to say, I think you can do a describe in here. I think you can. It's case sensitive. The SQL commands aren't case sensitive, but the database objects are. Bam. So there's your describe statement is how you find out what's in a field. So I want to say like, yeah, so you start to see all the different suppliers. So that's the database. But what I couldn't find on this website, and if any of you were working with it, or using it to kind of check out all these different functions and whatnot, and you find a description of that database, let me know, because I could not find one, which would be really helpful to have an ERD or some sort of data dictionary for it. I mean, you might be able to like click on it and yeah, that just does a select star. That's not as good as seeing how things are related and what your foreign keys are and all that kind of thing. But I'm pretty sure this is the Northwind database, and I got an ERD for that, which might help. Real quick while we're at it, I'm telling you, hours went by and I was just a pig in the mud working with code. It was I loved being a programmer. I put that away. Let me connect real quick. I want to see just how close our Northwind is to that Northwind tables. Ooh, we got a lot more in the real Northwind database. Yeah, similar. The names are slightly different, but it's going to be very similar in its relationships, in its relations. But yeah, if anybody can find a diagram for what this little MySQL database is on this website, please let me know. Otherwise, let's do some Python. So go ahead and bring up, actually in the classroom, if you have not yet, go to Programming with Python. And there are 2 Jupyter notebooks here to download. Python IPO Basics and Decisions in Boolean. Or you can go over here to Files And if you're not seeing this, please let me know, somebody, really quick. And then over here in the left panel, you can click on Python notebooks. Are y'all seeing that same view as I am? If you go to the classroom,
Which two, Don? You said,
3 and 4.
okay.
But I think I'm going to remove them from there, and I'm learning Canvas as I'm going, kind of how it operates as an LMS, and in Blackboard and one other LMS I've used, you can upload multiple files to an object. So I could create one thing in the classroom that said Python notebooks, and they'd all be in there, but you wouldn't have to see them all, scrolling down the screen like that. So this files area in the classroom, you should be seeing this. Does everybody see Python notebooks? Okay, cool.
Yes.
Yeah. So you're going to want, you've already got 2, beg your pardon. Make sure you've got 2 through 5, 2, 3, 4, and 5, and put all of those in your notebooks directory. And I will get started. Am I still screen sharing? The whole screen?
Yes.
And I unpaused recording. Man, I don't remember doing it, but glad I did. Let's see. You want to go to bring up Jupyter Notebook. Of course, I keep everything on my OneDrive. Documents. Python notebooks. Okay, so in this class, we're doing IPO basics. Now this, I really don't want to spend a whole lot of time on, because this notebook won't take very long. So you can follow along in Jupyter Notebook, or follow along as I'm sharing my screen. Some of this is refreshing your memory. 8 rules of good programming. And remember, there are only 3 kinds of statements. Sequential, which is what we're finishing up today, the notion of a sequential statement, and we're going to do decision and repetition today. So we're going to be doing if, then, else, and looping, while looping, for looping today. Okay, so we can run this cell. Yeah. You sure I haven't done this one? Man, it's redundant. Run that, and we get hello world. And yeah, variables, you can store stuff in a variable. We've done that before. I'm not really sure why Mike, guess he's working with undergrads, right? Okay. Now, here's a good one. Have we, if I'm not sure if we've seen concatenation versus the 2 different ways of printing 2 different strings. In the print statement there, the first one is you're printing, the variable, the identifier, first name, and then you're printing title. And it inserts a space. It knows, or by default inserts a space. But if you concatenate 2 strings, notice how it doesn't. There's no space on the second one between Arthur and King of the Britons. It concatenates them with absolutely no auto formatting, which is something to remember. And a lot of these behaviors, I mean, they're in the book, but you just have to remember them. So yeah, we've have we not done like basic math and whatnot? We have, haven't we?
I think so.
Yeah. So, I mean, you run these cells along with me just to get through it. So remember the int converts something to integer, because a lot of times by default, Python wants to assume its floating point, which depending on what you're doing, can either cause bad, confusing formatting or an error because you're passing something that's expecting an integer and you're passing at a floating point. But you can basically convert everything on the fly too. So yeah, we did this one before. Was it? It's 12, but everybody was thinking it was. I was thinking it was 18. Anyway, that shows you the order of operations. And again, these are sequential programmings. Okay, so here's the what could have been, woulda, coulda, should have been an exercise, but it shows the break-even quantity. You know, when you've got fixed costs and then selling price and the cost per unit. Fixed price is like the cost of your factory. Unit cost is how much material you put into that one thing that you're selling. So that's your break-even quantity formula. But here we're doing just some simple assignment statements and printing it out. So run that. And notice it defaults to floating point. Everything defaults to floating point, even though you assigned it integer values. But you can, if you really want, you can convert just for the print statement. You can convert, or you can print the integer version of that variable.
I have a question, Don.
Sure.
When you assign these variables, what is the memory of that? Is it as long as your kernel is open, or is it?
Yeah.
Like,
yep. That's exactly what it is. Or until you reassign it. I don't know that there's a way. There may be in advanced Python. There may be a way to forget a variable, to drop a variable. But basically, when you're working with Jupyter Notebook, or if you're working even with an integrated development environment, once you declare a variable, or once you use a variable by assigning a value to it, you don't declare variables in Python. You just use them the first time. Yeah, it's in there until you're done with that kernel. But if you're working in multiple tabs, the other kernel doesn't know that you defined a thing called cell underscore price. So they're unique to your to each kernel, to each instance of Python running. So
but you'll remember it in the same notebook, right? So it's not just each cell. Like
right. It's the whole notebook.
Okay.
And then there will be times, if you work with Notebook enough, that you'll run something down here that's, sequentially it's after something else. But if you didn't run it beforehand, you know what I mean? Sometimes you click on a cell and hit run, you assume everything else before it has run. And you just got to realize that that each cell is independent, unless you say, is it cell run all? Yeah. Cell run all will start at the top and run through and run everything without question. And you'll get all the error messages. And if you have an infinite loop, it'll sit there and loop, and but it'll try and run all of them. So there you go. But I wanted to I wanted to prove to myself, and you guys can do the same thing. I wanted to prove to myself that I did not convert the type of break-even quantity. There you go. Yeah. So when I did int on it, it was a temporary conversion purely for this print statement. If I wanted to no kidding change it, I believe I can say break-even quantity equals int of break-even quantity. I think. Let me see if I blew it up. Yeah, you can change the type of that variable, which you very often want to. You want it, if you know you want that thing to be an integer, go ahead and int the variable so that it changes the type um, uh, at the time that at the time that you use it, at the time that you create it, and even if it's somebody typing it in um, on the screen. You go ahead and as it is input to your program, you go ahead and make it whatever type you want it to be. So here's an example of importing a library to make this thing run faster and not take too much memory. The Python powers that be have kind of pulled functionality out so that the base language does a lot, but it doesn't do everything. And there are libraries of functions, libraries of code um, that let you do more things. And math is one of it's called the Python standard library. So that's the thing that lets you do things like square root. So let's see if this won't explode on me. Import math as MT it's an alias, kind of like we were doing in SQL. There are in the Python world, there are conventions, as we've talked about, and MT is what everybody calls math. So when you're reading Python, that's just the one you want to use, just because that's the way it is. Okay, so let's run this and see what we get. Okay, the roots are 1 and -4. So this, yeah, did some quadratic equation math, used the MT dot square root function, and of all that stuff, and assigned it to disk underscore square root. And then this is a lot of basic algebra that I don't necessarily deal with. But one thing to notice here is the format function inside of the print statement. We have been printing just the variable, just print a variable or a variable, comma, and some characters in a string, comma, another variable, so we've been doing that. But you can also, here, root plus is a variable, right? That we calculated up here. So we're printing the format of root plus, and then you have these formatting strings that are in a cell below. But I don't worry about it because I don't care about pretty output. When I'm dealing with Python, I'm not doing it to get pretty output to put in front of management. But you might be, and in which case you'll want to get more familiar with the ins and outs of the print statement and how it how those format strings work. But that's basically just tells it, use 3 decimal points at 0.3f. Okay. And yeah, concatenation, the plus sign, you can in a print statement, you can concatenate or join together perfectly as many strings as you like. So go ahead and print that one out, or run that cell. Yes, we had to explicitly tell it to use the space after the comma. Yeah. See, here's getting to your point, Laura. Code inside cells can be run independently, but everything that has already run matters. Yeah. So you don't get fresh memory or whatever. You know what I mean? You don't get a fresh environment in between cells. Everything that you've run for a given notebook is out there in memory. So IPO, input, output. Okay. So here we go. Run this. Now this is your first look at, I believe, getting input from the screen, right? Which is going to be something you're going to want to do when you're writing programs to play around with this functionality so that you can test different values. You know what I mean? So when you write a program that uh, that does much of anything for this class, at least, you're going to want to use this input statement. So you say to use this, you say a variable equals, and input is a function, just like print or int or any of these other functions that we've been dealing with. And then you put your prompt string in there. That's what's going to display to the user. What day of the week is it today? And then print day of the week. So run this, and yeah, it'll take input until you hit enter, just like you would think. What is it today? It is fun day. And it prints fun day. So that's how you get input from the screen. Let's, I think type is a function. Let's run this again and make sure. Oop. You have, I forgot a second parenthesis there. What day of the week is it today? Dawn day. Yeah, it defaults to string if you put multiple characters in there. But let's rabbit hole. Let's do it. I want to see what happens if I put in a, it's 3. What day is it today? What's the third day? It's still a string. I gotta wonder though, if I had put 3 in the first time, if it would have cast it as an int instead of, or a floating point instead of a string. Anyway, yeah, Python and data typing. It'll come up over and over and over and over and over again. It's loosely typed, dynamically typed. So data types are something that you have to kind of manage that you don't in other languages. And that's just the way it is. Okay. Run this cell. What happens? How can we fix it? I don't know, Mike. Let's run it and see what happens. How many students donated? 4. We raised 20 total. I think that's what's wrong is the I'm not sure what he was getting at. Do you guys want to goof with that a little more? We raised, we could do int of that stuff. I think. See if I blow it up. Probably forgot a parenthesis. Oh yeah, that's the really annoying thing. Python will stick parentheses in for you, or Jupyter Notebook will. 4 donated. We raised 20. Yeah. So converting it to an int made it print as in 20 instead of with the point. But if I was smarter at the print formatting parameter, I could format it and not goof with the value, which is down here. So I should have been able to format. Let's run this and see what the effect of these different formats are. So yeah, this is where you start to get into scientific notation, inserting commas in between values and whatnot. I believe there's a truncate function. I know there's a truncate function in SQL. Anyway, that's printing and formatting. If it turns out to be something that you want to learn more about, we can certainly go into it more. Like I said, I don't goof with it. I just use these data types as they come out by default, which for me has pretty much worked. I haven't found a need to mess with it yet, doing analysis. And then but those are formatting strings. And again, there are tutorials out there. If you're needing to format data in Python, you're going to want to get comfortable with it. And then we can run this next cell. Accounting format. Oh yeah, where it justifies the price of the house, $30,000. Yeah, and it pads with zeros so that everything comes out in the same width. So the decimal point will line up. Hang on, we have a message from Captain Obvious. Variables can vary. This is just reiterating magic numbers in your code. Try and avoid them, because like this 0.0885, you'll forget why that was magic. You'll forget why that number meant anything. So it's better. That's all we're going through here. That's all. The only point we're trying to make is it's better to assign it somewhere and then use sales tax rate, use the identifier sales tax rate in the rest of your programming, so that you only have to go back and adjust sales tax rate one place, because 0.0885 may be the sales tax rate, but if you're using a bunch of magic numbers, it may be a magic number for something else too. You know what I mean? 200 may mean more than one thing, and if it's taken out of context, you're changing it here but not changing it there. And anyway, that's good programming practice. Is if you have a magic number, a meaningful constant, use it in a variable. One last programming exercise. Okay. I think this is something that actually could have assigned to you, but I think it's a little early in our tenure for that. But we can run this and play with it, goof around with it. So I'm going to go on break. We're going to go on break. And the next notebook we'll look at is number 4, where we can start to look at if then else logic, or branching, conditional branching. Any questions on this notebook? I know I left some things vague on purpose. Okay. In the next hour, we'll get into conditional branching. See you back at 10:30. Pause recording. And we're back. So sharing screen again, entire screen. Remember, you always want to close and halt each tab, each notebook. Close and halt. And then we are doing number 4, decisions in Boolean logic. I'm hoping that I uploaded a nice clean. I may not have. Sometimes I play with these things on my computer after I've uploaded them to you, and it makes me confused. Okay. Because I start goofing with things and I introduce errors. So we'll figure it out. We'll fix it. Okay, so what we've been doing, assigning variables, doing every step of your program, period, are sequential statements. But a lot of times you want to do something if a certain condition is met, or if not, if that condition is not met. So this notebook's all about that Boolean logic, which is true or false. If something is true, So that equates to either yes or no. It's true or it's not. Then you do a certain leg of the code. Otherwise, you do another leg. So this first little bit here is just showing you um, what that means. Boolean is 0 and 1. If you might have heard it, a binary. Boolean is the same thing. It's 0 or 1, true, false, on, off. There's only two conditions. So remember our checking operators are greater than, less than, greater than or equal to, less than or equal to, and then double equals. Remember when we're checking to see if a equals 1, we got to use 2 equals. The single equal sign is the assignment operator to assign the value of 1 to a, or whatever the case may be. So you can have just an expression. You can literally look at these first 4 cells, and Python will evaluate it. So it'll evaluate it as a Boolean by default. It knows what you're trying to do. So 1 is less than or equal to 1. Is that going to be true or false? So if I run that, true. 1 is less than 1. I think that's false. 1's not less than 1. 1's equal to 1. False. Is 1 equal to 1? Yes. Is 1 not equal to 1? That's false. See, so when you see, these are that's the power of Python. It does all this stuff without really typing much of anything. But you'll use that in an if statement. You'll say if, and you won't use literals like this. You'll say, if a is less than 1, then do something, kind of thing. And we'll have some practice in that. Remember, these operators are testing the relationship by making a comparison. So yeah, even if you say, exclamation point equal, it's not doing anything to the variable. It's just checking yes or no. So there are like 3 different combinations of Boolean logic. And Mike talks about making sandwiches, I believe here. Yeah, you're at your parents' house for the summer. Remember the audience here, guys. It's college students, You're at your parents' house for the summer. Mom asks, would you like a sandwich? That's either a yes or a no. Okay. And then you got another decision to make. You want ham or turkey. So now you have 2 possible branches. And then our third case of logical if then else is Dad says, I need your help. You're gonna mow, pull weeds, trim the branches, or take your sister to the pool. But you're gonna do one of those, right? You're gonna do one of those 4 things. You're not gonna make up your own choice and violate Dad logic. So that's just a lighthearted look at how you can do conditional logic in computer programming. So we do 2 choices first. He could have done 1 choice, but it'll make sense when we get to it. So this is your classic, if this condition is true, then do this stuff. Else, do this. So very narrowly, if a condition is true, you're going to do these statements under here. Else, no matter what else is going on, you're going to be doing this stuff. No other logical treatment or anything like that. And one thing, a couple of things here syntax to notice is this colon after the if. Condition will be, if A equals B, if last name equals Dean, and if profit is greater than 4, and any sort of comparison check like that is going to be what's in your condition. But then notice there is no condition after the else. So if that condition is false, it's going to do this leg of the branch, of the conditional branch. But you got to remember that colon, and then this indentation matters. You want to make sure, and it will automatically, when you see that colon and smack return and smack enter, it automatically knows, oh, I'm doing a block of code here, and it will indent for you automatically. The block of statements after the condition and colon are indented, and there is a blank line after the block. So after your else, make sure you've got a blank line. When the condition is true, the statements below it are executed until execution reaches the else, and then it stops. When the statement is false, those are skipped, and the else leg of the if then else block executes. Okay, now I was goofing around with this one, so let's execute this next one here and look at what happens. So I'm going to put just above and one thing when you are writing code and trying to figure out what your code is doing, is it's good to put a diagnostic statement, a print statement in your code, so that when you run it, you know where you're at in your code. That's the only reason I put this print I am in the income equal to or under 45K branch, so that when I ran it and saw the output, I would be able to check my logic. Okay. Now for something this simple, maybe not such a big deal, but man, you start, you get, 3-level deep if then else inside of a for loop nested inside of a while loop, and it gets pretty hairy. And sometimes a diagnostic inside of all that code, letting you know where you're at in it, it can be really helpful. So yeah, so if income is less than or equal to 45, you do this bracket here. Otherwise, you do everything in the else branch, which is where we wound up in the income over 45K. And then so you can set something like tax rate independently in those two legs, and it does one or the other. Okay, and then you see the blank line after the else block, right? Before the tax underscore amount here, the blank line before this statement. You got to have that to let Python know that you're all done with this if then else block. Any questions on how a two-choice branch works? For those of you maybe that haven't done any programming. Okay, yeah, it's all in the condition. Sometimes you can, that really matters. Sometimes you're saying equals when you really mean less than or equal to. Sometimes you get the less than or equal, the less than or greater than sign backwards. Sometimes there's an error and you're off by one number. Like sometimes you really meant 45,001 or something. So it's really up to you as the programmer to make sure that the logic in that in that branching works appropriately. But that's your two choices. That's when you have two things that you want to do, this or that. Okay, yeah, here we go. But then sometimes you got two choices and one of them is to do nothing. You don't have to have the else block. Okay, sometimes you just want to do something as you're running through your code, and if some condition is true, you want to do something. Otherwise, nothing. You just keep going. Is that making sense? That's in this next block here.
Hey, Don,
By default, go ahead, Thomas.
if let's say I want to put a space in there for readability but keep going like in the same statement,
Mhm.
would I just need to add parentheses around the whole thing, or
A blank line, you might want to add a comment. Like if you just like if you wanted to put a blank line in between these things here,
Mhm.
like for readability.
Yeah.
Let's see if that doesn't make it barf. Actually, let's try it without, Thomas. See what we get. If I had see what happens here. Enter income. We'll do 45,000 again. It didn't seem to matter. It didn't seem to bother it. I'm trying to think. If you don't have the line, I think is what the problem is, as opposed to if you do have the line. Let's play with that. Try this one. One before I go back and answer that question, I wanted to. So this if with no else. Let me clean it up a little bit. By default, you're going through, and by default, your income is high. So only if somebody goes against the default and enters an income of less than 45,000, you execute this stuff. That's kind of logically problem solving wise when you would use something like this. It comes in handy. But let's figure out this. Let's test this theory. My gross income shouldn't matter. I am in the branch. It didn't seem to matter. I thought for sure you needed that blank line afterward. I'll have to Google it, Thomas. Oop. Okay. Now, more than two choices. So you have more than an if and an else. In other computer programming languages, and in generic computer science, it's called a case statement, where you have different cases. In this case, I want to do this. In this case, I want to do something else. In this case, I want to do something else. But in Python, it's an if, elif, else. Elif kind of stands for else if. In fact, other languages use literally the word else if. But Python uses this sort of structure here. So what this is often kind of handy for is if you're doing something like a menu almost. You write a little program that does something. If you enter 1, it does some stuff. If you enter 2, it does some stuff. Else, if you enter Q, it goes down to the else leg and exits, say. So there's some important things to know about this if, elif, else block. They're tested in order. So the order that you put them in your program is up to you, and it matters. If a condition is false, it will not do that leg, and it goes to the next condition and checks it. If it's true, it will do what's in that leg, and then pop out to the next line after the else. It skips to the end of that entire decision block. Okay. Always use else at the end. And yeah, it's what happens if none of the other things wind up being true. Okay, so this next one, let's see, I got an error right now on my screen. Let me see what I did. Oop. Your final numeric grade. I might have just entered an invalid number. Say 93. Your final letter grade is A, duh. So why? How did I make it barf, I wonder? Run. So see, this is checking. So here, I'm typing 82. If final letter grade is greater than 90, greater than or equal to 90, it would do that leg. But it's not. So elif, it's greater than or equal to 80. It is. But so is 92. But what happened was when I typed in 92, it satisfied that very first if and ignored everything else. So that's the importance of going in order here, especially if there's an order to the responses like this one. So that's what they're. Now I wonder, I got to wonder what I did. I probably entered a string. And remember, one of the very first words of wisdom from Mike was all input is evil. Don't trust it. When you're getting input from the user, if it's for real, you've got to go through the logic to make sure they're not entering garbage. I think I might have put a string. Yeah, there you go. So I was trying to do the int function on a bunch of letters. See, I did the conversion without checking to see what was in that string. So there you go. That's how I made it barf. Input, invalid input. So yeah, it does all of these things. Even if you put like which, I scored a 4,000. Yeah, you get an A. Now it's up to you as a programmer to error check these sort of things. As far as the input values or any of that kind of stuff. Okay. So that's if you've got two things, if, else. If you've just got one thing, you just put an if, the colon and the indentation is what you got to remember to do a block of code like that. And then multiple things. If there are multiple legs that you might want to go, you got that if, elif, else. And you can nest them. Here's a double condition. Sometimes you want to do something and then something else. If then and then, you can nest these conditions just like you would think. You just got to take notice of the indentation here again. So in this block of code, we're checking for the income level and setting a tax rate and the tax bracket. However, we're checking their age. But if they're so I guess we're wanting to discern between old poor people and young poor people. Otherwise, if they're not low income, all we do is this stuff down here, which has no check for age or anything else. So this is a good example of nesting if statements. So give that a whirl, run that one, and see what you get. So I'm going to say my income is low and I'm young. Low and you are young. So that worked. Now I'm going to say my income is low and I'm old. Income is low and you are old. So it's working. So yeah, when you're testing these sorts of things, you need to put in values that will potentially break it. You want to put something right at the limit of what you're asking with your logic and everything. So that's how you do check within a check. And you can have those, man, I've had those 5, 6 layers deep. You know, like I said, within a loop, within a if. I mean, yeah, just depending on what you're doing, it can get pretty complicated. Now here's, this next one down here is a really good example of why you would do an if, elif, else block. And that's doing like a little menu for if you were writing something that did some analysis maybe, and there was a couple of different options, you could kind of do a text menu, simple text menu like this. So you can run that one. And what if you print 4 cell current output clear, run. Oh yeah, duh, the menu. And you choose 1. Your entry was not correct. Please try again. If menu choice equals 1, your entry was not correct. Is it a type problem? Run it again. Your entry was not correct. Typing in 2. I'm curious if it's the type. You guys got any guesses as to why this is barfing?
It's probably the integer. Could you also put quotes around the numbers and have them be strings, and then that fulfills the condition too?
You could. In fact, that may be what. I'm just trying to think of why this thing barfed. I thought I'd error-proof my code here, but I keep goofing with stuff. Are y'all seeing the exact code I got here and getting the same error?
Let's see.
Are y'all getting
Yeah.
the same error I am? Let's
Would the int go before input rather than inside the input parentheses?
It might. We can try that too. So we're gonna int the input. Yeah, that's what it was. It was a type problem. There you go. Data types in Python. I'm telling you, man. You start working with this stuff to try and get it to actually do something, and it's frustrating. So that's what happened. Data type mismatch. But that's a good example of, you know, multiple, and then within each of these you can have another if else, if else. You can nest those just anywhere. There's no like limit or whatever. And we can do and, or, and not in our check. Let's see what our example of that is. Can be combined with two. Oh yeah. Like if it's greater than and equal to 90 and less than or equal to 100, say. So in between 90 and 100, you use the and to make multiple criteria. But even with all these ands and ors, they still resolve all of those multiple conditions. All will still resolve to either being true or false. And it's just like you would think with English. It's if this and that, then something. If this or that, then something. And not reverses it, and not logic gets goofy. So I just it's you use it with caution. Try to build expressions with the most critical criteria in the first position. Okay. For and, if the first criteria is false, there is no need to check the second one. Yeah. If you, yeah. For or, either one, so you got to check them both. Inside a range, and or to check for values outside a range. Okay. And I like Mike's point here. Avoid them unless there's no other option. And at times there will be no other option. You've got to, there's complex logic and you just got to do it too. So let's see what we got here. 1059. We're doing our final grade thing just like we did before. And then I'm doing your gross income. And we're yeah, if you're poor and you got an A, you're getting a big bonus. If you're poor or, and guys, I'm saying that for shorthand. I don't mean you're poor if your income's less than 45,000. I don't need you contacting HR on me. LIF, low income, or you made better than A, you're getting a gift. Better than a B, you're getting a gift card. So either of those can be true. If they did not get an A, you say thanks for taking the class, and else not sure who lands here. This is a great exercise. Let's see what we get. I'm going to try and land on the else. My final grade is a C. Oh, numeric grade. My final grade is a 72. My gross income is greater than 45,000. I'm trying to land in the not sure who lands here. Let's see if I got the logic right in the block. Nope, thanks for taking our class, because the first one with 72 and 47,000, I didn't satisfy the either of these two, so we didn't do this one. On the next one, I didn't satisfy either this or that, so we didn't do you're getting a gift card. If I didn't get an A, thanks for taking the class. That's what so that satisfied that one. Else, not sure who lands here. Anybody else good at word problems? Anybody else think of what input would get you to not sure who lands here? Maybe somebody that's high income and they got an A? Let's try that. You're getting a big bonus.
I think you put your income as the grade, and then
I sure did. Good grief. How do you deal with it? I mean, if I had to sit and listen to me, I'd be hurting myself. I gotta, my hat's off to you. Okay, final numeric grade. What did we say? 95? So we're doing an A and we make a lot of money, right? No, because I got an A. How about we're making a lot of money and we got a B? No. Anyway, yeah, it's trying to backwards figure out the logic of a program is something you will have to do often if you're working with other people's code. So I'm trying to think. That's a good mind bender. Is there any way for this else to be satisfied? Because guys, as a programmer, you are writing this, and it is really easy to write stuff that's not going to work, that never checks. You can write while loops that, that something that'll loop that never satisfies and never stops. I wrote one just this morning getting ready. I think it's in the it's in the next notebook. And your output cell just keeps growing, and it says INF in it, infinite, and it's just going and going and going and going and going. And you finally got to hit like stop the kernel up here, the stop button. But anyway, so Boolean variables. There are actually a Boolean type of variable, like we have integer and floating point. We have string. There is a Boolean data type, and this one's a good example where you set a Boolean equal to the keyword true, and you don't have to say if past class equals true, double equals. You just say if past class. So the way you name them is important. So we'll run that one. Your final numeric grade, 45. False. Because I didn't print. Now I could do, how could I fix that? Damon, how would it didn't print that I failed. How would I fix that?
Would you put an else statement at the very end and then put print you failed?
That sounds like Aaron. I was picking
Yeah.
on Damon.
It's okay. I don't mind.
Else, what comes next? The colon. And it automatically indented. See, when I put the colon in there, it automatically indented. There you go. So you decide as a programmer how that logic goes. Okay. All right. It's almost break time. I've got another one I want to do, another notebook. So why don't everybody take a break and then come back and write these. Particularly the first this first one. Take a crack at them, and we'll do a little screen sharing. They call it being in the hot seat, sharing code. So we'll come back at 11:30. 11:30, and if none of you are satisfied that your program works and that you're ready to share it, then I'll give it a shot, and we'll take it from there. But hopefully you guys will be able to make at least that first one work. Write a program that displays the sky descriptor based upon the cloud coverage entered by the user. So the user's going to enter a number, and then based upon that number, it's going to do either clear or partly cloudy or overcast. Very similar to your examples up there. So you should be able to cut and paste and make it work. All right, let's come back at 11:30. Pause recording. And we're back. How'd it go, guys? Yeah, I had trouble. I mean, not logically. I'm not sure what's going on with Python, but I got a couple of times I would run it, and it would just asterisk at me. Like you guys have seen when I'm teaching up here, a couple of times you run it, and it just seems like it's in an endless loop. Well, that's not possible without looping. This little program should end, but like the third or fourth time I would run mine, it would just asterisk at me, and I'd have to say file, close and halt, and close that tab, and then when I started over again using the exact same volume that seemed to make it hang, it worked fine. Anybody else have a similar problem to that, or were you still working on the logic?
I realized you couldn't put the percent sign in the input fields. Like the first exercise says percentage of cloud cover.
Mm-hmm.
And then when I first entered it, I wrote like the actual percent sign. And it
Oh, and that's a format symbol or what? Yeah.
I had to write in my statement, don't enter the percent sign.
Ah, so you entered. Oh, I see. When you provided you put the percent sign in your answer. Yeah. Okay. Oh, error checking user input is huge. Well, not just user input, but input coming from files, and yeah, that's enormous. And it's all up to the programmer to. So who got it to work more or less? That wants to share their screen. Not Laura. The only other camera on. Damon, how about it, man?
I didn't quite get it to work. I was trying to figure out how to do it without the and or the or, and didn't quite get there.
What you got? Can you share? Are you allowed to share your screen? I think I can let advanced sharing options. Who can share? All participants. Yeah, you should.
Yeah, I honestly, I don't have too much to like really show because I was still thinking through that part. I'm sorry about that. Because that was part of the, I guess, requirements. You can't use and or, and that was my first thought on how to do it.
Okay. How about you, Lindsay?
I've got nothing on that. Sorry.
Not even anything? I mean, you didn't type anything in? You didn't try the problem, or
No, I still don't have access to that. So,
you don't have Python loaded?
yeah, whenever I tried to get the MySQL stuff going, it seemed to break my Jupyter and Python stuff. So I don't know what I did wrong there, but.
Okay. How about Andra?
Want to see my failures?
I do.
Okay. Why is it showing me everything else but what I need? I guess we'll just do my whole screen. Okay, so at first I tried the if percent of cloud cover is less than or equal to 30, then print clear. And that gave me a syntax error. So then I tried like this, and that also gave me a syntax error.
You're
It's the same thing, so I don't know what I'm doing.
you don't have your input statement there. You need to set
I had that. So like, are you talking about this?
Yeah, you need to set your
So I
you need
did
to ask
have
the user.
this,
Mhm.
but it did the same thing. And so this would be
Like what?
percent that cloud coverage.
Yeah, go ahead and type that in. Well, it can't be. Is that a space in between those?
Yes.
You got to have an underscore.
Okay.
There you go.
That was probably
Cloud coverage equals, and then down now. There you go. Oh, it'll check you out.
I'm lazy.
That's a good programmer.
Okay.
Okay. So
Is
they
that
are.
okay?
So you're converting it to integer. I wound up having to do that too. Okay.
Hmm?
Okay. So you're saying if it's greater than or equal to 100, make the
Yeah,
descriptor
so I
equal
was
to
looking at
overcast.
this one because it's kind of going backwards, like
Yep.
from highest number to lowest. Is that correct?
That's the way I would do it. Yeah, because if
Okay.
you're
To not use the and or.
yeah. So yeah, start with your 100 bracket and then keep going.
Is this okay as descriptor or should I do print?
No, setting a variable descriptor is what you want to do there.
Okay, so then we do this thing. Does this need a underscore instead of space also?
It does.
Okay, that's where I'm going wrong.
There you go.
Okay, so then we just do the same thing over again, right? So this would be would it be 99 or 71?
I'll let you think through that just for a second. So
Mhm.
the next bracket starts at what number?
71.
Yep. So you'd use the lower value of that bracket. So now anything that drops down, anything that's greater than 71 is gonna execute in that. You need quotes around cloudy.
Oh, that's right.
Did you notice when you put the double quotes in, it put two in for you automatically?
I did not.
Yeah,
But I see that now.
it's automagic. I don't know. It could be really annoying. Sometimes you just want one quote. And then
And then I end it with else. Is this equal or? Oh, wait a minute. So how do I do the else?
you do a else colon, following along with the way you're doing the program, you do an else
I see.
colon, which is, yeah, and then you would do your descriptor clear. I think that's what you're
Yes.
looking for.
Clear equals 0.
No, you want to set your descriptor to clear.
Oh, I see.
Because yeah, this is, if they enter any number that's lower than 31, actually, you're going to say descriptor equals clear. I think you're missing an R there in descriptor.
That's never good at spelling.
And then blank, and then a blank line. Now that may just be convention. It doesn't seem to make it error. And then you're going to print out your output.
Use underscore.
Oh, yeah. Go ahead and enter a value, but you're going to want. Go ahead.
What value? Is
You're
this
going to want
to
to
test it?
enter anything. Yeah. Anything but, yeah, any numeric value. So it ran, but you don't have a print statement after where you've got that comment that says use underscore instead of space.
Mhm.
At that same level, you're going to want a print statement that says print, quote, the weather today is, unquote, and then descriptor. You know what I mean?
So under, you said?
Print, yeah, that's fine. Print, then you open print, yep, and then you want to put like in quotes.
Oh, that's gonna mess it up.
There's a way to do it, but I'd have to look it up real quick. But use single or double quotes and just say the weather today is, and then outside the quote, it's a
Meaning,
and then
what do you mean
comma,
outside the quote?
right where you're at, comma, descriptor. So you're passing the print statement, a literal string, the weather today is, and then the value in descriptor. So go ahead and run that, see what you get. Error.
I didn't seem to like this blank one.
Well, hang on. It might be case sensitive. You've got descriptor in capital D in your print statement. Change
Well, I
that
was
to
thinking it's looking at that, is it not?
Well, it doesn't matter what's going on in that.
Oh, I see.
There you go. Yeah,
Nice.
it's case sensitive.
I see.
So a capital D descriptor is a different variable than a lowercase d descriptor.
So it's looking at here, not here.
Correct. Yeah, that up there is a markdown cell. So it's just for documentation. It has nothing to do with anything.
Okay.
It doesn't have anything to do with your code. That's it.
Sweet.
Anybody go at it a slightly different way? Thank you, Andra. That was very brave. Zoom.
Happy to show my failure.
Zoom applause for Andra. Okay. Anybody go at it a slightly different way?
I did it in the reverse order, starting with clear and up, and it seemed to work.
I would think if you reversed it, it would always satisfy the first one. Like, you know what I mean? If you put share your screen, Aaron. Show.
Yeah. Okay.
You use less than.
Yeah.
Yeah, you can do it in the other order, and check for less than, as opposed to doing it in descending order and checking for greater than. Yep. So what's wrong with you? Go ahead and run it. Yeah, nothing wrong with that. There you go. Oh, I apologize, Aaron. I thought you were telling me you did it in the opposite order and it was giving you trouble, but no, you got it.
Oh no, yeah,
yeah.
it's working. Just yeah, everything was inverse
Yeah.
or backwards.
And really, that's an excellent illustration of the fact that you give a problem of any complexity at all to two different programmers, and it's like they're like songwriters. You know what I mean? You will see different solutions, different ways to skin the proverbial cat, and that's good. So I'm glad you're trying the second one too. I was gonna give that for homework. Okay, I did the same thing.
I have a question real quick.
Sure, Andra.
So does the slash in today's, does that keep it from messing up with the apostrophe, like the possessive versus the quotes? I see there's under print today's, there's a slash.
Oh yeah, that slash means use the next character as a quote. That's how you do it, right? Aaron, isn't that right?
Yeah, like I think if I took that out, I'm not sure if it would run or not.
I think it bars. I think it'll. I apologize if.
Oh, maybe it does.
I wonder why.
Maybe if I use single quotes here, then it probably wouldn't.
Yeah, there you go. If you're using double quotes, it seems to not mind the single quote within, or the apostrophe, whatever that is, apostrophe.
Mm-hmm.
There you go. But that's classically, that backslash means take the next character as what it is, not as a formatting character. If you happen to use something like that, like you'll see it in
STR?
String that will convert whatever you've got, like descriptors and numeric up there, because we've been dealing with numbers, but Aaron's converting it to a string data type, which affects the way it prints out.
I see.
And he can concatenate it. He can use that plus sign instead of doing a comma.
Cool. Thank you.
Cool. All right. Way to go. All right. Okay, let's knock out looping. So that next week we can just do some problem solving. We can just do some programming. I think between sequential statements, you guys got that, and if then else, if else logic, and loops, you guys will have the basic constructs and can start doing some brain teasers on your class during your class time. So let me say close and halt, file, save it, and then close and halt. These things auto save, but I like to hit the floppy disk anyway. And our next one was what? 5 repetition, right? Yeah. Okay. Share screen. Okay. So there's a couple kinds of loops. Loops are pieces of code that execute kind of like an if, only they keep checking. They keep checking the if and doing it over and 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 over until that check says stop. So there's basically 2 types of those, right? There are condition controlled, like I was just talking about, where it checks that condition and does it again if that condition is true. So that's kind of like do while not done. And if you set done to true, and then it gets to do while not done, or not done is false, so it pops out of the loop. But then there's so that's called a while loop in generic programmer speak. But then there are times when you want to do something a set number of times, and in computer science speak, that's count controlled, but it's a for loop in programmer speak, because you're doing something generically. We would say like for I, that's the looping variable. That's the convention. Everybody uses I by default. I don't know why it was that way 35 years ago, and it's still that way today. So you could say like for I equals 1 to 10, and then you would do the next block of code 10 times. So the first one we'll go over here is a while loop. And it looks a lot like an if else block. You put the colon at the end and you indent the stuff inside, and then at least for readability, I think you want a blank line afterward. I'm going to have to do a little Googling and see if I can come up with the answer to that. So as long as the while condition is true, it's going to do all that. And you can do not logic and you can do ors and all that kind of stuff, but eventually all of that logic gets boiled down to either being a true or a false. And while the condition is true, it will do the loop. And when it's and even if the while condition becomes not true inside the loop, it hasn't hit the condition yet, right? So it's going to keep executing, and the next time it gets to the while condition, it will not execute. So you got to remember that sometimes the logic of your loop, when you're writing a while loop, you kind of want it to just quit, and it won't quit, because it's gonna do everything in that loop until it gets back to checking the loop again, and we'll see it. So it's a pretest, meaning that it won't do the loop ever if you don't satisfy the condition before you enter the loop. You know what I mean? If you're writing program along and you want to do something while you have an account balance, if you don't set the account balance to what you want it to be so that the while loop starts, it'll just go right past it and go to the next executable line after the while loop. So here is an example, and while loops are where you get in trouble with endless loops. The whole do while more electricity, because it just keeps on going and going. Okay, so I worked on this morning, so this should work. So we enter an initial deposit amount, and then we look at compound interest, and we exit after we reach our target. Okay, so let's say I'm going to put $20 in, and I want to make 50. We won't go nuts here. I want to make $50. The interest rate is in decimal format, so let's say 20%, so we don't loop too many times here. We'll make $50 pretty quick here. So yeah, in year one I got $24 because that's what I deposited. Oh, I'm sorry, that's my deposit plus 20%, so $4. And then the math gets a little bit more floating pointy after that. And at the end of the loop, one time, what you're seeing with that 6 down there is this print statement of printing years. So while balance is less than target. So it's, even if you see how we went above I went above my target, right? And that's okay because you want to do it that one extra time because the only time you want to stop is after your target exceeds or after your balance exceeds your target. Does that make sense? So that's a while loop, and they can get as this balance is less than target is pretty straightforward logic, but they can get pretty hairy. Okay, that's it. And um, and then you can, I think, do we have nesting here? I can't remember. Seems like we nested some stuff. Yeah. There's a little bit before we leave here, because you can nest a while inside an if, inside a while, inside a for loop, inside. I mean, and it can get as hairy as you can imagine. So a for loop executes a certain number of times. The basic syntax is your loop counter in this up here in the markdown cell when it says for target variable in. Target variable is normally I. That's just a convention, like I said. So you could say for I in, and then this is actually a list. So the for loop is expecting a list. So it can be straight numeric, 1, 2, 3, 4, 5 times, or it can loop for a number of times for a set of, like maybe you want to do a for loop and you've got a list of cars. It'll do it that many times. It'll for however many cars are in the list, it will do the for loop for that. This is kind of like a Pythonism. If you tried to do this with a lot of other languages, it would barf. But like for example here, these are numerics. It's using the position in the list, not really the number in this thing here. So run it, and I apologize, it's getting a little more confusing than it should be. So for item in that list of items, it'll print item, and the value is there, but it's doing it as many times as you have items in this list. So that's kind of goofy, right? So that's not the way you normally write a for loop. So luckily, there's a function that basically returns a list of numbers that are in a certain order. And that's just the way they programmed it in Python. So you're going to be using a range function. And that will do something like you would think, from 1 to 10 or from 10 down to 1, say. This is the format. It needs at least one number. So you'll say like for I in range 6, we'll do the loop 6 times. By default, it does it in ascending order, and it will the value in I will change each time through the for loop from 0 to 1 to. Now, what's goofy about this is if you by default it starts at 0. It's 0 based, and the other thing that's goofy about this is by default, if you want to do something, for I equals 5 to 10, you have to put 11 in here because Python is they call it it's exclusive. It doesn't do the last value. It does everything but it. I don't know why. It drives me nuts. And it's something you just always have to pay attention to with Python, is it being, most things are 0 based, and a lot of times when you're giving parameters of like, from here to there, it's up to but not including that second number. Frustrating, but you get used to it. So there you go. And then the third value would be your increment number. So I think I gave you a negative down here. And here's an example. So this first one, we're doing it 12 times from 0. So num is our I in this case. So we have a starting quantity and a year, and this is kind of a goofy exercise, but I still use it. It's calculating the price of bushels of soybeans based on the quantity and the previous year's price. And don't worry about the logic. Just look at the for loop. Num will iterate from 0 to 1 to 2 up to 11 and then stop. And you can use num or whatever your counter variable is. You can use that inside of the for loop to let you know which time through the loop you're iterating. So run that. So we're starting with, say, I don't know what, 20 bushels, and the price is $5 a bushel, and then you get 12 years of output, and it's doing this goofy 0.1 times quantity 20 minus that to come up with the price. But the basic gist of it is it's incrementing year that you input inside the for loop each time. It's doing its calculations, but num is incrementing automatically. You don't mess with num. In fact, don't mess with num inside of a loop. If it lets you do it, it'll completely goof up the logic. I don't even know that. Let's try it. See what happens if I make it 15, which you'd think might end it after 1 year. Let's see if it even lets me. Start quantity, what did I say, 20? And price was 5. It's like not even letting me mess with it. I shouldn't have said anything because now I'm at a quandary.
Maybe if you put num before year and quantity, it might change.
You think? Let's try it.
Not sure.
I'm trying to remember the language I have the most experience with really was back in the day. It was called Pascal. And I want to say if you did this, it would blow up. It doesn't seem to mind me doing that. I'll have to look it up. But don't, as a matter of practice, don't modify your loop variable inside of a for loop. Interesting. Yeah, you can let the user tell you how many times they want to do something, or you can use a variable in that upper limit. And this next one just shows you what I'm talking about. It's the same goofy bushels of a soybean price, but instead of a fixed number of times, you're letting the user choose how you're letting a variable set how many times you run through the loop. So we'll do the same kind of, and then how many years? Let's do 6,000. No, we don't want to do that. 3 years. So it only did it 3 times. So there you go. Any questions so far?
So you can name that variable anything. I see that's what you were saying about using I. It doesn't have to be specific.
It does not have to be. The accumulator variable or whatever it's called. No, I mean the counter variable. It can be anything. I'm just telling you, you see I a lot, and that there's nothing more to it than it's just the way it's the way it's always been. I and J, for whatever reason, you never name anything that's a single letter like that. But for some reason, we get away with loop variables like that. Now, it starts getting complicated when you've got for loops inside of for loops and whatnot, so that I stop using I and J and K and I start using something meaningful, so that I can kind of tell when I'm reading the logic. It helps me remember why I'm doing what I'm doing. Yeah, this next one I stuck in here so you guys could see. You don't have to just go up. If like I wrote a program way back in the day that I wanted to descend from 30 or whatever down to 0. So I had to run the loop backwards rather than do some goofy calculation with the count, with the loop variable. So it's easy enough here. If you want to go from a large value down to a smaller value, you just use a -1 for your increment value. Like, remember, by default, this is 1 +1. So run that. 10, 9. So it starts at 10 and does it 5 times. Let's see what happens if I change that to just 1. It does it not at all, because it made it outside the loop. There you go. So, I mean, logically, you can't go from 10 down to 5 by +1, right? So I guess that makes sense. Interesting. Okay, so an accumulator, now this is putting a variable inside of a loop so that it'll grow however many times you're in that loop. And then when you pop out of the loop, you have that aggregate total is all that's getting at. And yeah, it really is good to initialize variables outside of a loop. And the first time you use them, it's really good to just set them equal to an initial value, an initial data type in Python for that matter. So what are we doing here for item in range? Oh, match. You say how many times you wanted to do this. It's just adding up a like doing like a calculator, you know what I mean? A number of items. So run that. We'll only do that, say 4 times. Enter an item cost 34 and 23 and now it should tell me, yeah, the total for 4 items is 165. So that's just showing you that inside of a loop, you can work with a variable that will then be meaningful to you when you're outside the loop, when you're all done. And there's some more print formatting for us. And yeah, he alluded to it. Nobody popped up, said, hey, what's that plus equal thing? That's a shortcut for incrementing count by 1. Plus equals. It's shorthand, and I think Mike even says, yeah, use them only if you're comfortable with them. So yeah, x equals x plus 1 can be written as x plus equals 1. And C programmers really love to be brief. So that's the increment character in C is plus plus. C plus plus means add 1 to C, and that's where they came up with the name for C plus plus. So it's shorthand, but I write things out because my brain instantly recognizes what x equals x plus 1 means. Okay, and then there's these other ones, but like I said, they're shorthand. You don't have to use. A sentinel is a special value that marks the end of a sequence of items so the loop knows to terminate. You must be sure it is distinctive so it is not mistaken as a regular value in the sequence. Ah, that's just saying if you're writing a piece of code like earlier, we were calculating the number, letting the user pick how many times to calculate the soybean thing. You could put a while loop around all of that, so that when they enter some special value, it stops doing it. That's all this is. So you run this, and as long as I don't enter negative 999, it's gonna an item cost. It's gonna keep adding these things no matter what I do, no matter what I type, as long as I don't type negative 999, in which case it pops out of the loop and prints our total. So that can be helpful if you're wanting to run something until you tell it stop running. And of course, we have nested loops. This is an interesting one. I gave this as a programming challenge to high school kids, and some of them got it done in seconds. But if you wanted to print a right triangle, that gets bigger than the number of rows that you do, you tell it the number of rows, and it will increment through. Remember, it'll increment through a for loop, the outer for loop here. The number of rows that you put in plus 1, remember, because the range function, if we didn't have that plus 1 there, it would always make our triangle one less row than we asked for. So you got to remember to put something like that in there if that logic makes sense with your range function. But then inside of this thing, say I want to do 7 row. Well, I'll run it one time so you can see what it looks like. Or y'all run it and see what it looks like. Inside of our outer for loop, and that's a term you use when you have nested loops. You have the inner loop is this for J in range, because it is looping inside of this for loop. So every time this outer for loop loops for the number of rows, this J loop will loop however many times it's going to. So you have this concept of inner and outer loop that you got to kind of keep track of. Mentally. And then the other thing I wanted to print out or point out here is we're printing those stars. You saw all those stars running across your screen, right? Print by default prints onto a new line, so that every print statement results in something starting on the next line. Well, if you're building rows of asterisks, you don't want the new line until you're done printing that row out, right? So that's what this print statement is for. It executes every time you're done printing a row, which is what the J loop does. The inner loop prints the row. The outer loop puts you on the next line. Is that making sense? The outer loop is what puts you on a new line, and then the J loop increments each time. It prints one more character than it did before in each time. See, because it's using I the outer loop counter. So each time it for each row, it executes one more time than the row you're on. Is that making sense? And if it's not, it's okay. This is this is a fairly quick deep dive into nested for loops. So it really helps to work with them. But yeah, running this thing, number of rows, let's do 6. So yeah, that outer loop executes 6 times, and inside of it, this inner loop executes first it executes 1 time because I is 1. The second time it executes twice because I is 2. The third time it executes 3 times because I is 3. See how that works? So it's nesting the loops. Any questions on that logic? It's just a few lines of code, but it can be a
So
little
that
confusing.
+1, that's the end of the range, or is that the increment?
No, that's the end of the range. That's yeah, and you want to add that 1, or it will always short you. Yeah, because it's going to go up to, but not including that second number in the range function.
So whatever you give it, it will never go to that actual number. You have
Correct.
to add.
It's exclusive of that second parameter, which I don't know. Why would you do it that way? You know what I mean? It doesn't make sense to my.
Yeah, SQL is inclusive. You do like a between.
Yeah, most other languages are that way. When I first started learning Python a couple of years ago, I was like, what? But apparently, Damon, you know R fairly well. Is R default to being 0 based and exclusive like that, like Python does?
I don't think so, but it might be. I don't do a lot of for loops or a lot of counts in there to be able to say so. But I've coded in VBA, like Visual Basic Application, and I know for sure that is the for loops and whatnot. We have to take into account that it'll start on 0.
Oh, sure enough. So, yeah. So when you're working with like a list of things, the first list isn't the first. The first thing in the list isn't the first. It's the 0th. So I don't know. It's just Python. So that's how that works. Nested for loops. And here's another. We were talking about lousy user input. This one here lets you validate your input. We're going to ask them one time to enter a deposit amount. If they put a negative amount in, it'll tell them and until they enter a positive value. Now there's lots of other things you could do to validate input, but that's an example of what you might do. So as long as you keep adding negative numbers or entering negative numbers, you're going to be stuck in this while loop. And then it just goes and does the same thing that we did before with the compound interest. Only here we're using, instead of balance being less than the target, they're using not logic, while not balance greater than target, which is the same as while balance is less than target. So you guys got it, as programmers will decide whether or not you want to use not logic and not operators and whatnot. And then of course we got the plus equal. I didn't run this, but I'm pretty sure I did this morning. I entered. So yeah, let's see if, yeah, doesn't like negative numbers, which is one form of validation. And I want to get up to $30. Interest rate as a decimal. Yeah. So say 30% interest. Woo, banner year. So in 5 short years, I reached my target. Okay, guys. So that's conditional. What you really think of probably when you think of programming a computer and doing logic puzzles and whatnot. You've got these notebooks. You're, you know, I encourage you to use them. There's certainly other materials out there. I put in the classroom, I showed you if you click on files and click on Python books, I got a few in there. So if Python is heavy in your future, there's no end of tutorials and whatnot out there. I'll walk everybody through at this pace. But if I'm going too slow, there's just a whole world of resources out there. And that World Wide Web school does a Python. They've got a Python tutorial as well, and it's equally informative. All of this kind of stuff you can play with. And when it says try it yourself, it's the exact same thing as a Jupyter notebook. And you can write as extensive as a program as you want over here on this left-hand side. Instead of printing hello world, print hello Dawn. What's with hello world? Everybody's got to do a hello world program. Hello Dawn. There you go. So that's, yeah, this World Wide Web Schools is awesome. Okay, guys. And we'll get back into SQL next time and start doing some no kidding problem solving with Python as we move forward. There's still like different data types to work with and whatnot before we worry about analytical libraries and graphing and all that sort of stuff. And we got to there's a lot more to talk about in SQL, right? A little bit more to talk about in SQL. Different types of joins, and then different ways to like group data together so that you don't have those repeating fields quite so much. And so that'll be next couple of weeks before we get into data visualization and Power BI or whatever you want to use. Any questions before we go for the day? And I see you on Tuesday. All right. Wish me luck, guys. I'm getting my second COVID shot today. My wife was down for the count, throwing up on the couch, sick, with a second Pfizer shot. So fingers crossed. We'll see how it goes.
Good luck. Let us know.
All right. All right. We'll see you guys on Tuesday. And
Take care.
Chaz never did make it, did she?
I don't think so.
I don't think so. I still got to work on her spreadsheet. Okay, guys. I'll stop recording and I'll see you guys on Tuesday.
Thanks.